Okay, section 2, chapter 11, we're dealing with stoichiometric calculations. We have a lot to cover in this section. So you're going to use your mole ratios to go mole to mole. You're actually going to use mole ratios in all of these calculations. So get used to those. And these are the steps to solving mole to mole. So you could figure out the moles of your reactants and figure out the moles of your products. But first you need to always balance your equation so you have correct ratios, and then you're going to use the ratio to solve the unknown. So your generic equation is A plus B, and it produces AB. So let's say you're given the amount of A. You're going to multiply that by your ratio of AB divided by A.
Okay.
And that will give you your moles of AB.
Of AB. Yeah, fix that one.
Okay, nice.
It's all
right. You know what we're saying. You're going to have an A in there.
There you go.
Okay. So let's practice. You have potassium plus water produces potassium hydroxide and hydrogen gas.
All right, so we got to balance.
Yep.
First step in everything. Our K's are good. Then we got to go to the H's. And the H's, we have 2 on our reactant side, and we've got 3 on the product side. So I'm going to make that odd one probably an even number. That makes 2 K's. That makes 4 H's on our product side. So to get 4 reactants, we need to multiply by 2. It gives us 2 oxygens, and we've got 2 oxygens on our product side.
And 4 hydrogens, 2 potassiums, 2 potassiums. Okay, good. If you have 0.1 moles of K, so this is what you're given. You're given the 0.1 moles, okay? You want to figure out how many moles of hydrogen do you have.
All right.
Well, okay. So what are we going to start with?
We're going to start with our given, 0.100 mole of potassium. And you just told us on the generic term, we're going to multiply by the ratio. We're going to put what we want to find on the top, and what we want to find is our H2, which is 1 mole, because the coefficient is 1. So 1 mole of H2 divided by our 2 moles of potassium.
Got it.
And now our potassium mole and our potassium mole can cancel each other out. 1 on the top, 1 on the bottom. We're left with moles of H2. Once you do your math, you would find out that it's 0.05 mole of H2.
Okay.
Pretty easy if you ask me.
Okay, now we want to look at how many moles of water does one need to form 6.5 moles of KOH. So if we go up here, now you're starting with 6.5 moles, and we're trying to figure out how many moles of water do we have.
All right.
Do we need to produce the 6.5 moles? Okay, so we always start with our given.
Yep, 6.5 mole of KOH. What we want to find is the mole that's going to go on the top, which is our water, which is 2 moles of water. And going on the bottom is 2 moles of KOH, which the 2 and the 2 are pretty much going to cancel to a 1 and a 1. So we're going to take 6.5 times 1 divided by 1. Yep.
So you're left with 6.5 moles. Whoa, that's a 5 moles of water.
Yeah, not too bad.
You can read it, 6.5 moles of water. All right, let's talk about mole to mass conversions. So now we're going to go one step further from mole to mole. So you are going to, again, balance.
Okay.
And now if you have the number of moles of a reactant or product, but you want to calculate the mass of another product or reactant, you're going to use this. So always start with your given. We're going to, again, go from A to AB. So we're given the moles of A. We are going to do the mole ratio of AB over A.
Okay.
Then we're going to multiply by the molar mass of AB. What are the units for molar mass?
Gram per mole.
Good. So again, your moles are going to cancel out, and all you're left with are grams of AB.
Okay.
Okay, so balance. We have 1 sodium, 2 chlorine, so we need to have a 2 here, a 2 here.
Yay.
Let's look at our problem. Determine the mass of NaCl produced when 1.25 moles of Cl2 reacts with excess sodium. That just means you don't need to worry about how much sodium you're given because it's in excess.
Means that you have more than what you really need.
Right.
So we're going to start with our 1.25 moles of chlorine. And anytime we want to go from one substance to the other, we always have to multiply by the mole ratio. So if we have chlorine, chlorine's going to have to go on the bottom, and that's a 1 mole. What we want to find is the NaCl, which is 2 moles of NaCl. So 1.5. Well, our mole.
2.5.
2.5?
1.25 times 2.
Oh.
That would give us 1.5 moles of NaCl, but we're not done. Now we have
It
to.
should be 2.5.
Oh, yes, it should. You know what we're talking about. 2.5. Oh, stop it. Now it looks like 20.
All right, so now we're at moles here. Now we got to go mole to gram. Now, you should know from chapter 10, you can use your triangle here. You can go mole to gram by multiplying by the molar mass. And we've got molar mass is labeled gram per mole, then the gram can go on the top, mole goes on the bottom, so it can cancel that unit out. But what we have here for NaCl is going to be 58.
Okay. So 2.5 times 58.
58 came from our periodic table, adding up Na and Cl,
Yes.
by the way.
Yes.
145
Okay.
grams of NaCl.
Yes, you gotta tell me what is your formula.
You were running out of space.
I am. So
pretty
you
easy.
could put this all in one line. That's
Yeah.
how I prefer to do it.
Yeah.
But if you
wanna
want to
show 'em
break
how
it
to
up,
do that
sure.
real quick? So what Mrs. Kelly did first here was we took each piece and we got an answer, and then we did the next piece and got our answer. But what you could do is you could set it all up together. So she's just bringing the information from the top equation, and we're just going to multiply each ratio and put in the molar masses as one big, huge, long step. So if you've got all these numbers on the top, and by numbers I mean anything other than 1, so we got 1.25 times the 2 times the 48. You would times all 3 of those together and then divide by any numbers that were on the bottom that weren't 1, and you'd end up with the exact same number. So it's just another way to do this. If you set it up that way, we're okay with it either way.
So the notice that the reason that I like this so much is that you see what cancels,
Right
and
away.
you know that you're set up correctly, because at the top you end up with grams of NaCl, and that's what your problem's asking you for.
The other thing is it's going to keep your answer in your calculator, and it's going to give you the most precise answer instead of you writing down a number and rounding it off because you don't like writing all the decimals out. So we kind of both like the bottom way to do it, but do what you need to do.
That's the old school way. All
Are you
right.
calling us old?
Yeah.
All right.
All right. Mass to mass conversions. So if you're given the mass of one reactant or product, you can find the mass of another.
Okay.
So we're just going to take the last one step further. We're going to start from the mass, go to moles, go to mole ratio, and then go to the molar mass of the other.
Okay.
So again, if we have A and B producing AB, you're going to take the mass of A divided by the molar mass of A, or you're going to end up having grams on the bottom and moles on the top if you are multiplying across. And then you're going to multiply by the mole ratio, and then by the molar mass of AB.
Okay, so triangle, mole ratio, triangle is another way to say it.
Yeah. Practice.
Woo.
First we got to balance.
All right, so
Okay.
N's,
2
we
and
have
2.
2 and 2. H's, we have 4 and 2, so we got to make water a 2. And that makes 3 O's on the right and 3 O's on the left. We're good.
Good. Okay, 25.
I like how you started way over on that
I
side
did,
now.
because this is a big formula. Oh, why am I
All right.
crooked? Okay.
25 grams of ammonium nitrate will decompose into how many grams of water? So we're starting with our reactant. We want to find out how many grams of product will we actually be making from this. So what we're going to do is set up the little portion of mole to gram, which means you're going to take your grams and divide by the molar mass. So that would be one of your triangles, or you can set it up just like this. And then you can keep going and put in next the mole ratio.
Okay.
Now we want to get rid of ammonium nitrate, so that mole ratio is going to have to, that mole coefficient is going to have to go on the bottom.
Right.
And we want to find water, so the 2 moles of water is going to go on the top.
Okay. Now what?
And then we're going to multiply by the molar mass of water, which is 18. 18 gram per 1 mole of water.
Okay.
Your final answer is going to be 11.25 grams of water. So here, we would multiply across all the way to the top. 25 times 2 times 18. I'm ignoring any ones. Get that answer in your calculator, hit enter, divide by 80, because that's the only other number on the bottom that's not a 1.
Right.
And you get 11.25.
Mm-hmm.
Or you should, hopefully.
These are, what do you say, the longest?
Yeah, they are.
So,
But they're not hard. I mean, you've got your triangle stuff to use. You just got to make sure your units are canceling. And the biggest problem I think most students have is putting the correct ratio.
yeah.
You want your answer, whatever your answer in needs to always go on the top, and what you started with always goes on the bottom.
So if you forget to balance, you're not going to have the right ratio. If you balance incorrectly, you're not going to have the right ratio. The other thing that I see a lot of times is people don't add up their molar masses correctly.
Yeah.
They're just rushing through it and forget to add the 4 hydrogens or something. So that would also give you an incorrect answer.
Yep.
All right, next one, more practice of the same problem. So we already know that we balanced it to have a 2. So now we are asking, in order to produce 20 grams of water, how much ammonium nitrate is needed?
Okay.
So we're going to start with our water.
20 grams of water. Divide by the molar mass, which is 18. You should have that one memorized by now.
Yeah.
We use it so much. Mole ratio is going to be a 1/2. I can say that quicker than you can write it, unfortunately.
Yeah, I'm getting faster. Look at me
You
go.
are.
Look.
I am
Whoa.
impressed because it'd be taking me forever. All right, then we're going to multiply by the molar mass of
that
ammonium
80?
nitrate. You're good. It was 80. And then your final answer is going to be 88.9 grams of ammonium nitrate. NH4NO3. Yay!
Okay, so start with your mass that's given. You're going to divide by the molar mass.
Yep.
You're going to do your mole ratio. You're going to multiply that by the molar mass.
Done.
Done.
Last problem. Yay!
Okay, that's it.